Let's solve this system of rational equations. And our first move will be to set these equal to each other since they both equal y after all. So starting with this one, I have x over x minus 3 minus, and then that's 3 over x minus 4 equals. Now this minus, I'm going to go ahead and put it in the numerator. So just get it out of the way. So that's going to give me negative 3 over. Now I'm also going to go ahead and factor this so I can see what I'm dealing with. So x squared is x times x. 12, alright, I'm thinking 3 times 4. Now it could have been 2 times 6, but I'm seeing this negative 7. And 3 and 4 add up to 7, so this looks promising. Specifically, inner plus outer must equal the middle. Inner, I have 3x. Outer, I have 4x. If I want to get negative 7, both of these need to be negative. So negative and negative. Also, happily, a negative times a negative is a positive 12. So this is working. Now, the way I solve equations like these is I make the denominators the same. So I have x minus 3, but this has x minus 4. So I multiply by x minus 4. That's okay as long as I also multiply the numerator by x minus 4. Now these are the same. What about this? Well, this denominator has the x minus 4, but it does not have the x minus 3. So I multiply by x minus 3 in the numerator and the denominator. So now my denominators are the same. So once you get the denominators the same, you can cancel them out. Now I'm going to be careful here. It would be a good time to mention the excluded values to make sure that none of our solutions are illegal later. So the excluded values are x cannot equal 3. All right, looking at the x minus 3, set that equal to 0. That tells you that x cannot equal 3. Also, x cannot equal 4 because of the x minus 4, setting that equal to 0. All right, so watch out for that. Now, before I go any further, another common mistake is what to do with this negative sign. I want to take this negative and put it right up on the 3 so I don't forget to distribute the negative. So what I usually do is I'll change this to a positive, and then I'll put the negative up here. All right, whoops, it disappeared. So now I can cancel out the denominators. All right, so I've got this new equation. So I'm going to distribute as I go. So this will be x squared minus 4x. And distributing this, I've got negative 3x plus 9, negative times negative is a positive, is equal to negative 3. Combining these like terms, I have x squared minus 7x plus 9 is equal to negative 3. Alright, I'm going to get 0 on one side. Anytime I see I have x squared and x, I'm going to get 0 on one side and factor. If I add 3 to both sides, then I get x squared minus 7x plus 12. Now this is looking very familiar. X squared minus 7x plus 12, that's the denominator that I just factored a minute ago. So this is again going to factor as x minus 3 times x minus 4. So again, that's going to give us x equals 3 and x equals 4, right? If I set these each equal to 0. So these would be the x values of my solutions. And normally I would be talking about making a table of values because when you have a system that involves y equals, that's reminding us that we need y values. So normally I'd be saying, hey, we have these x values of 3 and 4. Now we're going to find the y values. But I'm not going to say that because these x values are the excluded values. X cannot equal 3, x cannot equal 4. So none of these values are okay to use. They have to be thrown out. So I have no more x values. That means I have no more solutions. So the answer is C.